Right. Good evening, ladies and gentlemen. If anybody has any problems of a technical sort, please please do let us know via the chat or the question and answer. If you have any questions, you won't be able to ask them really live, but you can enter them in the Q&A. And I'm delighted to welcome Roger Bailey from the Tideway project, who I'm sure will introduce himself far better than I can introduce him. So I'm going to, without further ado, hand over to Roger. I'm actually running the PowerPoint from the museum, and Roger is at home on an iPad. So it'll be me advancing the slides, which is why you'll hear Roger saying next or something of that sort. And you might see me, which I'm sure is not very welcome, rather than his face at times. I'm just checking that there's no problems there. Someone's saying, getting an echo, how do I adjust? I'm not sure that I know the answer to that. If other people are having an echo problem, let us know. I might be able to turn the record level down or something like that. Somebody else says no echo here. So I think we will proceed, and I will ask Roger to start speaking. Roger, over to you.
Thank you very much, Martin, and good evening to everyone on the call. Yeah, I'm Roger Bailey. I'm the Chief Technical Officer for Tideway, which is the company building the Thames Tideway Tunnel through London. And I've been on the project for 8.5 years now. So it's great to have seen it move from the planning and sort of feasibility stage through to now we're about 60% through construction. So I've got a presentation here, which I hope you find informative. There's a little video in it as well to give you an update of the latest activities across London. And then I'd be very happy to take questions at the end on any aspect of the project that you're interested in. So if I could get to the next slide, Martin. So yeah, our challenge is to build a new sewer for London to prevent the frequent pollution of the River Thames. For those of you who are not aware, if you go back a few years, because there's been several improvements made around about 5 or 6 years ago, typically 40 million tons of sewage was going into the river from the overflow from the Victorian system. I'll explain a bit more about that later. So our challenge is to prevent that from happening and to clean up the River Thames. So it's not just, the vision is not just to clean up the River Thames, but to promote a change in the relationship between London and Londoners and their river. And a lot of that is about how we use the river during construction and how we hopefully promote the increased use of the river for all sorts of reasons after construction. So next slide, please, Martin. So a bit of a history lesson. In fact, if you go back far enough, the first environmentalist in London was in fact Henry VIII. Back in the Tudor era, of course, the palaces that he had were in Chelsea, Greenwich, Whitehall, Westminster, that sort of thing, and spent a lot of the time going up and down the river. And it was in using the tides to get up and down and using the watermen to do that. And as he was going through the centre of London, he realised what was in the river was not particularly pleasant. This is back in the 16th century. And he made a decree that if you were within the city walls, you had to have a cesspit. You know, in those days, of course, if the king made a decree, it was followed. Otherwise, you were down to the tower or worse or whatever. So everybody dug their cesspits. And then there became a sort of tradition of what became known as the gong firmers, and these are the night soil workers who'd come in and they'd empty out your cesspit and take it out and spread it on the fields, which in those days, at the outskirts of the city were like Lincoln's Inn Fields or Moor Fields or whatever, quite close to the city that we know today, or within the city that we know today. But in those days, they were on the outskirts. Now that sort of arrangement lasted for a couple of 100 years until we get to the sort of 18th and then the 19th century. And in the 19th century, London expanded rapidly, as you know, and at that point, the density of housing got greater. The city got out; it started to build on those fields, and the whole sewage sort of problem became worse. With instead of going into the cesspits, which had sort of become a little bit difficult to run, it went into the tributaries of the River Thames, and you can see here those tributaries, quite a lot of them, and they became effectively the open sewers of London. The consequence of that, of course, was in the 19th century a series of cholera outbreaks in the city, because people were taking their water for cooking out of the same places that they were putting their sewage into. And I think something like 40,000 people died in London of cholera in the sort of 1820s, 30s, 40s. Unfortunately, that didn't make anything get done by the authorities until in 1858. You may have heard of the Great Stink. And the Great Stink was when the river it was in the summer, the weather was warm, hadn't been much rainfall to dilute the fluvial flow of the Thames, and the river was really rank, and the smell pervaded the Houses of Parliament. And in those days, the people thought that cholera was transmitted by what they called the miasma, through the air. So if you could smell something rotten, then you were in fear of your life. And at last, the government of the day voted enough money for Sir Thomas Basil Jett to start to solve the problem. So the next slide, if you could, Martin. So his solution was effectively, instead of these tributaries to be going straight into the river, the tributaries would be intercepted by a series of interception sewers in the north, the middle, and the lower level, both sides of the river. And through a series of pumping stations along the line of these sewers, the sewage was intercepted from those tributaries, pumped up, fell down again, pumped up again, until it reached the east, and where you can see the branches coming together, where it says Northern Outfall Sewer. That was where we have the Cathedral of Sewage on the north side, the Abbey Mills pumping station, which pumped up these sewers up 20 or 30 feet before it fell under gravity down to the Beckton outfall, the Northern Outfall works down there in Barking Creek. And a similar arrangement happened, slightly smaller in scale, on the south bank, and that went down to the Crossness outfall works on the south bank. Now, this was all finished in the 1870s, and at that time there was no treatment of sewage. I'll come on to that a little bit later. But I think the interesting thing about this was that the formation of these sewers, particularly the low-level sewer, created the embankment in London that we know so well. So that sewer running along the river there to the north of the Thames. In building that, Sir Joseph Basil Jett created the river walls along the embankment, bridges. He created the district line running in cut and cover, and reclaimed sort of areas of land that were previously tidal all along the river there. So in many respects, north and south of the river, he cleaned up the river because this intercepted the majority of the flows that were coming into the river at the time. And back in if you go to the next slide, Martin, he was extremely far-sighted in his day. In 1860, the population of London was 2 million. He designed a million people. He also designed it to have a much higher capacity of people creating sewage as well, because I think the use of the flushing toilet was expanding at that time. And in 2019, the population of London is 8.8 million, and it's projected to rise to 16 million in the next 30, 40 years. Now, the sewer system is in excellent condition now, really very good condition indeed. It's working very well for what we call dry weather flow. So even with such a great increase of population, it's working very well. However, in the centre of London, it's a combined sewer system. And that combined sewer system means that rainfall from hitting the street in much of central London goes into the same network as sewage does. And that means that as little as 2 millimetres of rain can cause the system to become, in certain small areas, overcapacity. When it does reach its overcapacity, what happens is all the way along the river, there are what we call combined sewer overflows. You can see them there, often flat valves in the wall, very large cast iron flat valves, and so that they can keep the tide back because they're within the tidal range. And those flat valves let out the sewage as a sort of as a sort of relief valve for the sewage system north and south of the river. And it's through those valves that the sewage escapes when it's reaching capacity of the system. So it doesn't flood upstream into the low-lying areas of London. So what is the solution to this problem? Go to the next slide, please, Martin. So the solution to this problem is in three parts, really. The part you see there is a third part, which I'll come to in a second. So firstly, if you're going to capture these flows that aren't currently captured, they're going into the River Thames, you need to treat them. So the first thing that happened was that Thames Water, who we're in partnership with on this project, Thames Water upgraded all the sewage treatment works in London by maybe 50%. And that was done a few years ago now. They also put in, and you'll see it on the next slide, the Lee Tunnel, which was a very deep tunnel in East London, which captured the flows coming out of the Abbey Mills sewage treatment works, which I mentioned just a bit earlier. And that is the largest single inflow of sewage, or it was the largest single inflow of sewage into the river. So the upgrade of the sewage treatment works, the building of the Lee Tunnel, significantly reduced the pollution of the river from these discharges. But the final piece of the jigsaw is the Thames Tideway Tunnel, which stretches 25 kilometres from Abbey Mills, where the Olympic Park is, all the way across central London and to Acton in the west. It's very deep tunnel. It's 35 to 66 metres deep, goes underneath, it crosses, about 45 tunnels we cross, of which only 2 of them are below us. And that's 2 Thames Water assets in the west, where we're relatively shallow. Every single other tunnel we go under, and we pass, all the tube tunnels, post office tunnels, etc., on our way across London. It's 7.2 metres internal diameter, wide enough for 3 double-decker buses. It flows at a gradient of 1 in 800, which means it's not, there's no pumping needed to get it from the west to the east. It flows under gravity, and it's also self-cleansing. That gradient is enough to avoid the build-up of silt. It will hold 1.6 billion cubic meters of sewage. And for those of you who like this sort of analogy, the Wembley Stadium, if you imagine Wembley Stadium as a giant toilet bowl, filled to the brim with sewage, that would be about 1 million cubic meters. So we hold 1.6 million cubic meters in the tunnel. So really, and what that is pretty much is a large storm. So in the situation where we would generally capture pretty much all big storms. Some storms we wouldn't capture, very big storms, and also if there was one storm came very closely to the next, we wouldn't be able to pump out the tunnel, because down in the east at the Beckton sewage treatment works, there's and built under the Lee Tunnel a few years ago by Thames Water, there is the pumping station with 6 very large pumps in there, some of the biggest pumps of their nature in the world. They're pumping up about 80 meters below ground into the inlet works for Beckton. Now, the works done by Thames Water before us, the sewage treatment works and the Lee Tunnel, I think is about £1.5 billion in total investment. Our project is around £3.8 billion is the price tag for that, and that translates into a 20 to 25 pounds on your water bill. If you're a Thames Water bill payer, our capital cost is channeled through the Thames Water billing system. We're an independent company to Thames Water, but we are a sister utility in the respect that at the end, Tideway will be the owner of this asset, but Thames Water will be the operator. It's the sewage through their existing system comes into our tunnel, and then it flows into their facility down at Beckton, where it's pumped out into their sewage treatment works. So there's a massive partnership between the two companies. And just for those of you who are interested in why is that the case? So back in the days when the project was being developed, the size of the Thames Tideway Tunnel compared to the other aspects of the scheme, as you can see, it's significantly more expensive than the other elements, and it would have severely sort of stretched Thames Water's ability to raise finance and its risk in the marketplace, and it was deemed too difficult for Thames to take on such a large project on its own without some form of a government support package. And the government was unwilling to provide a government support package to Thames Water because it would create precedents with other water companies, and it was also would have covered more than probably just Thames's involvement in this project. So that is why Tideway was formed as an independent entity with a clear remit to build this tunnel and then own it as long as its license allowed. And that enabled the government to be comfortable to provide a government support package for that project, which is like an insurance policy of last resort, and that's been a very positive public-private partnership for us. If you could move on to the next slide, please, Martin. So just the route map for the project. Is you can see that over there where it says 24, that's the Beckton sewage treatment works. There's the Lee Tunnel going to the Abbey Mills pumping station number 23. And then we have the Thames Tideway Tunnel, which is mostly following the River Thames. It does go between Abbey Mills and the river by the Limehouse Basin, goes underneath the Limehouse Cut. It then goes through the centre of London and all the way up to Acton. There's a secondary tunnel at Greenwich, which goes up, which is slightly smaller diameter, 5 meters diameter, which joins the river, or the main tunnel at Chambers Wharf, which is 17. So these are this is the picture across London, and we've got 3 major contracts in where it's purple in the west there. That's the Western contract, Central contract in the middle, and Eastern contract. And at the moment, our tunnel boring machines on this map, we've got one tunnel boring machine a few weeks away from breaking through at Acton in the west. We have the second tunnel boring machine has finished the drive in the middle from 11 to 7 and has been dismantled and has been taken away. So that drive is complete. So the one in the middle going to from number 11, which is one of our main drive sites, to number 17. That tunnel boring machine is just between London Bridge and Tower Bridge at the moment. And the other two tunnel boring machines are now being placed into the shafts at 17. That's at Chambers Wharf of Bermondsey to go up to the Abbey Mills pumping station, and in Greenwich at 20 to go down there, and then that will then drill towards 17. So we can maybe come back to this. There may be, I'm sure, some questions about some of the details of this later on, but maybe if we could have the next slide, Martin. So this really shows a little bit about the sort of detail of how the interception works in the middle of a typical in London. This is at Victoria, as you can see, Victoria Embankment, sorry, not Victoria, Victoria Embankment, just along from the Houses of Parliament. So you can see there on the right where the tube train is, that's Bazalgette's embankment. That's what he reclaimed that area there, and he put the district line in. To the left of that, you'll see the sewer in the low level sewer there, and Bazalgette very far-sightedly put in a subway that's now used for all sorts of utilities above the sewer. We break in here, create a weir, and that weir overflows into that channel you see to the left, and it goes then down into the shaft through what we call a vortex generator. You can see a picture of that later on at Hammersmith. That spins the water down through around about, I think at this site, maybe 30 or 40 meters depth. It then stills it in a stilling basin type of thing at the bottom where those baffles are, and then it flows into a short connection tunnel and then into the main tunnel there underneath the Thames. So that is a fairly typical interception. This one, of course, is right in the heart of London, and one of the great positives about the project is we are creating a number of new pieces of public realm. You can't put a 25-30 meter shaft down without going out into the river in this area. There's just too much infrastructure and buildings and the like, and so we have created 7 or 8 or 9 great pieces of public realm along the river, including at Blackfriars, where we've got 1.5 acres. About 3 acres in total of new London in the river that we've created, 1.5 of it at Blackfriars. Next slide, please, Martin. So for those of you interested in the geology underlying London, in the west, we're relatively shallow, 30 or so meters, 35 meters or so, and we're through London clay then. As we go deeper, we go through the sands and gravels and variable beds of the Lambeth group, and then when we come out towards that, going deeper, we're down into the chalk. So the way we split up the contracts, east, west, and central, was generally to make sure that there was a fairly sort of a homogeneous type of ground conditions that the tunnel boring machines were going through, because tunnel boring machines like generally to drill through a similar ground. They can drill through lots of different ground, but you need to configure them so best to try and have your drives correlating to the strata that they're going through. So the next slide, please. So this is about the project timeline. I will actually go ahead, but 2016 was the start of construction, but actually this project really started life back in 1991 with the urban wastewater treatment directive from the European Union came in, requiring cities around Europe to improve the quality of the water in their watercourses by sorting out their sewage overflows into those watercourses, because the combined sewer problem that London has is very, very similar to a number of European cities, notably Paris, and also in America. Many cities in America have the same issue. So the Urban Wastewater Treatment Directive came in '91. In the year 2000, there were various studies done, and it was deemed by 2007 that the best way to solve the problem was by the installation of a tunnel system, upgrading the sewage treatment works and a tunnel system. Other solutions were, of course, considered, mostly looking at sustainable urban drainage and maybe looking to reduce the rainfall impact. But really, the problem was that to take the rainfall away and have a segregated sewer system would have resulted in virtually every street in the centre of London being dug up and every house being replumbed into that. So that would have taken 20 years and cost £20 billion. So it wasn't an option at that stage. So 2007, the government said to Thames Water, please go ahead and build the Thames Tideway Tunnel. They started with that, and then they got on with the sewage treatment works upgrade with the Lee Tunnel. And the Thames Tideway Tunnel was a lot of discussion about how that would be delivered, and it was agreed and delivered by a separate entity. That entity came into being in 2015, that's Tideway. And I can show you the shareholders' ownership of that in a minute. And in 2015, we signed all the contracts, came into being, and started construction. 2016, started tunnelling in 2018. Tunnelling will complete in, it probably will be, because of COVID-19, a little bit later than 2021, but not much later. And by 2024, will be completed and in service and cleaning up the river for Londoners. Next slide, please, Martin. Yeah, so these just are our contractors who are building the job for us. In the west, we have BMB, which is a joint venture between BAM Nuttall, Morgan Sindall, and Balfour Beatty. In the centre, which is the largest contract, we have a joint venture between Ferrovial Agroman from Spain and Lang O'Rourke. And in the east, we have CVB, which is Costain, Vaultsy, and Bassy Solitage. Now, these three big groups are building all the civils and mechanical works for the tunnel. They create the bones of the system, but we have a system integrator, which is Amy, and Amy come along and plug into the telemetry that's produced and left by the main contractors, and they then create the overall system that's then controlled from the Beckton sewage treatment works in the future by Thames Water. Gonna ask Martin to put it. He's left his post when he needs. There he is. Could you click us on, Martin? Thanks. So these are our shareholders. DIF is the Dutch Infrastructure Fund. Dalmore Capital and Amber are British infrastructure investors, and you'll know Allianz as the European sort of finance and insurance giant. Dalmore and Allianz are the largest shareholders of 30 or so %, and Amber and DIF are smaller. One, I think, very interesting point about this is that there's a huge amount of British pension fund involvement through Dalmore and Amber in the ownership of the tunnel. It is a very long-term investment, and these shareholders they came in actually after we got planning permission, after the project got planning permission, and they bid to effectively take over the job and take over the project and become a new regulated water company, a sister utility to Thames Water. Unlike companies like Thames Water or Southern Water that own assets all over their region, these shareholders just own the single asset, which is the Thames Tideway Tunnel. So next slide, Martin, please. So I mentioned earlier how we sort of we have a vision of leaving a better or leaving behind a legacy to London, and we have got some very across our legacy commitments are across environment, health, safety and well-being, economy, people, and place. And I'll pick up, I think, just a couple of things on here. Obviously, it's an environmental project. Building it will clean up the river. That's great, but we're also looking at lots of ways in how we build it, reducing carbon, reducing emissions, etc. On people, we're looking to employ. We are employing ex-offenders. We're employing apprentices. We're employing local people, and our contractors have targets in this area to make sure that we follow through on that. On health, safety and well-being, we've had a huge investment in our induction onto the project. Everybody who comes onto the project has a day in an immersive experience that is not only interesting, it's actually can be quite upsetting for people sometimes. It's very real, and they get subjected to a simulated very serious accident, and the impact on that on the colleagues of the person concerned. And at the same time, one of the senior members of the project team, the chief executive, my boss, myself, other executives, we come along to each of these groups of 30 and tell them why we do things here safely or not at all. That, coupled with a whole load of other things that we're doing, mean that we're not complacent, and we do have incidents, but we believe we are considerably better than we would have been if we hadn't done this. And we've learned a lot from so many other great projects in London over the last few years. Place I'll come to later. On economy, I think relative to this audience, obviously I'll focus here on the river. Our project requires 8 million tons of material to be moved to in and out to build it. All of our sites, as you saw, are on the river, and so we committed to using the river significantly for our project. If we hadn't used the river, if everything had gone by road, there'd been 500,000 lorry movements on the project. We've been able to get that down to under 150 or 50,000, which is still a lot, but by using the river. And in doing that, we have significantly improved the quality of the performance of the river operators. We were not happy that the existing river operators on the Thames could deliver a level of safety and secure operation for our project, because it was tripling the amount of freight on the river from the previous sort of typical levels. And we wrote a new code of practice. We set up a simulation, a digital simulation of the river in HR Wallingford, up in Oxfordshire, and we require every single boatmaster and mate to be validated up there on a 2 or 4 day course. That, coupled with the investment in new kit to push these barges, generally this one's shown here being pulled, but our barges now on the river can push and pull, and that makes a big difference to make sure you've got the best safety and best control of your barge going up and down the river. So we're very proud of that, and we've got through the peak of our marine logistics. Again, we're not complacent. Until the last barge is moved, we're we're on point to make sure things are done properly and safely. But we know from feedback that the operators on the river have significantly improved their capacity, their capability, and their record of safety, which is fantastic. So on place, if you can go to the next slide, Martin. So this shows if you're standing at Blackfriars on our site near Blackfriars Bridge and looking down towards Westminster, there will be this new 1.5 acre piece of public realm with what we call the black stages there, which are large sort of granite pieces of art that will also provide a focal point for people to perform and for this to become a real sort of a focal point for and a destination for Londoners going forward. So now I'll just wrap up with a bit about our latest progress and the video. So maybe if you could switch to the next couple of slides and play the video, Martin. It seemed to bounce up.
Lots of the guys came back with a ready-to-go attitude, just want to get on and build it. They take pride in their work and they like seeing progress.
We're towing TBM Selena up the Thames. It's a really special day for Tideway.
Today's been quite a big day for the Frogmore Connection Tunnel. Yesterday we broke through into the Harness Road shaft, completing our 1,060 ring journey. And today we're cleaning up the head, ready to start shunting it more into the shaft of Harness.
So we've been planning this moment for about 3 years now. So it's finally the end of tunneling for the Frogmore team. So this tunnel is capturing all the wastewater from the Wandsworth town area and we're diverting it down into Carmouth Road. We did have a few problems over the last month, especially since we restarted after COVID. Things were a lot slower. We couldn't bring the full gang, obviously due to COVID reasons, so we had to keep it as sort of a skeleton crew.
I'll kind of give you a bit of an overview of how we excavate and how we build a tunnel. So you can see here, these are concrete segments. So they come in on a train and they can be picked up, and we've got a kind of robotic arm that will pick them up and place them in position. The breakthrough brought a mixture of emotions, relief as we saw the nose cone come through where we wanted it to, happiness that we've come together as a team and finished the project. Also a bit sad that the gang's going to disappear fairly soon. We work in 2 different shifts, so we've got day shift and night shift alternating, and so you build up some rapport, some respect, and have a lot of fun together.
Behind us today, we're towing TBM Selena up the Thames to her drive site at Chambers Wharf in Bermondsey. This is the culmination of many years' worth of planning and a lot of hard work by a number of contractors and by Tideway themselves to make this happen. Today's a really special day. It's taken a lot of people a lot of time to plan this operation. As you can see, it's gone very smoothly so far. And to showcase it to the public in London is a really special day for Tideway. So right now we're more in the TBM and Skylift 3000 alongside Chambers Wharf's cofferdam. This TBM weighs around 900 tonnes with its cradle,
It's just under 9-metre diameter.
The significance of what we're doing behind me, this is a jack-up barge that can lift 3,000 tonnes. We're going to be lifting the TBM out of the river and driving it off. We'll sit there for a couple of weeks, but we will start tunnelling in about 2-3 months' time. It's the first time this has ever been done with a tunnel boring machine in the United Kingdom.
Okay. I think that's, yes. Sorry if that sound was not great at my end. I apologise if it wasn't great on others' end too. Just some photographs to finish off. This is a picture of the stainless steel, it's about 60 tonnes of stainless steel vortex generator lining tube being placed into our shaft at Hammersmith. The triangular section at the top there is a sort of a device that accelerates the flow into the vortex, and then it spins round as it gets inside it. So that happened a few weeks ago. The next slide, please, Martin. And these are just show the segments being taken into one of the tunnels, and a loaded barge moving past our offices at the Cotton Centre in central London. And I think the final slide is just some more photographs of the tunnel boring machine Selina being delivered to Bermondsey a couple of months ago now. Made in Germany, transported on the Rhine to Rotterdam, and then brought over from Rotterdam to London, and that is now successfully at the base of the shaft in Bermondsey and ready to drive up through to Abbey Mills and complete the eastern tunnels. And that, Martin, is my presentation.
Thank you very much, Roger. I hope you can, hopefully everyone can hear me, because I'm going to read out the questions. There are a number of questions for you, Roger. And I'm going to start with those that have been entered through the Q&A. We'll work through those, and then some other questions have been asked in the chat, and we'll come to those after that. So, first of all, Simon asks, are there any sluices or control devices anywhere in the system, or is it all fixed weirs and the system just deals with the flows as best it can?
Okay, good question. Firstly, there is nothing in the tunnel system at any depth. The deepest amount of mechanical or electrical was about 15 meters deep. So basically, the main thing is the tunnel is either open or closed, and normally it'll be open. And so if there's any flows coming into it, they will just come into the tunnel. Then they come in through those vortex generators down into the tunnel, and it flows down. And when the tunnel has filled up a certain amount at the bottom, usually about 5 or 6 meters depth, I think, but that's from memory, the pumps, it's probably maybe a bit higher than that, 10 meters, the pumps kick in and they start to pump it out. It pumps out better up with a head, so it's best to let the tunnel fill up a bit before you start pumping it out. And there are only 2 settings, and that's wet weather and extreme wet weather. And basically what happens is that you close the tunnel off earlier in extreme wet weather, because what can happen is you can get, because if you get massive storms in different parts of London coming in, very large flows into the tunnel, that needs to be controlled. And so we like to sort of keep a little bit of spare capacity inside the tunnel for various transient effects and things that would happen. So it is really very simple. Tunnel is open all the time. All of those CSOs are diverted into the tunnel unless the tunnel is shut because it's full, or because it's because it's full, basically. That's the situation. And in a typical, if you go back to 2014, we had about 65 million tons of sewage went into the river in 2014. It was a very bad year, those of you remember the rainfall. We modelled that, and with the tunnel, all the tunnel operating fully, it would be about 2.5 million. So even with all of this infrastructure, there is still a residual level. But as you can imagine, 2.5 million is a lot less than 65. So I hope that answers the question.
Thank you, Roger. Another question from the same person, Simon. I was interested to see the recent Port of London Authority notice about floating a large lump of concrete into place at Blackfriars soon. How confident are you that this work will work as planned? Has anything like this been done before?
Good question. I'm extremely confident. I was extremely confident before last weekend, and I'm even more confident now because it's been done. So we moved it. I was there on Sunday night. We moved it 100 meters. It's now in position underneath Blackfriars Bridge, and amazing piece of engineering planning, ingenuity, quality, and professional pride. So it's done. It's finished. And talking to the engineers involved with it and planning it. Some unusual aspects. It's quite a long, thin, and it's actually a boomerang or sort of banana shape. It's got a kink in it, which is unusual. They're used to floating out sort of immersed tube tunnel sections and things like that, which are a bit more regular. But with the right modelling and analysis, it's easy to do, easy to model it. And as we pointed out, I wouldn't say it's easy to deliver the whole thing because it requires an awful lot of foresight and engineering excellence. But it was done very smoothly, on target, on plan last weekend.
Thank you, Roger. Next question is from Sally. Is anything similar happening in South London?
Well, effectively, this is covering both of the north and the south. I probably focused on the north a bit more when talking about the low, but all of the CS, there are almost the same number of CSOs from the south as from the north. So it's one tunnel, and it has inputs from both north and south to solve the problem both sides of the river.
Thank you. And Simon again, he's having more than one bite of the cherry tonight. What's the purpose of the vortex in the vertical drop?
Okay, if you drop like a waterfall, you over 50 meters, you create a lot of cavitation and a lot of effects at the bottom of your shaft. What you want to do is to try and make that fluid get to the bottom of the shaft as easy as possible. And the best way to do it is to spin it, so instead of going over like a massive waterfall, it goes down like a water through a plug hole. So the vortex will spin the water into the tube, and then it goes down. It does entrain air into it as well, which helps to cushion it. But you don't want air bubbles in the deep tunnel as it goes down towards the sewage treatment works. So that is why there is that sort of that baffle inside the bottom of the shaft, which effectively creates like a bath at the bottom or a holding point for the water, and then the air comes out of that into the empty shaft above it, and then the sewage, the fluid that's going down into the tunnel has got a low air entrainment in it. And the reason you want to have low air entrainment in a deep tunnel is you can imagine air pockets forming in that tunnel under at depth. They will want to get out, and if you go to if you look at sort of other projects and other places, there are circumstances where you can get sewer geysering, where pockets of air under pressure will migrate up the tunnel and up a shaft. And if that shaft is very small bore, then all of the material and all the fluid in that shaft above the bubble will come out at the top under some pressure. So that's why our shafts are quite big, so that effectively, if any bubbles create under pressure, when they come to a shaft, they dissipate without any undue effect happening.
Thank you, Roger. Now, the next two questions are linked, so I'm going to ask them as one. Peter and Dennis have both asked about the spoil. Where does the spoil go? And Dennis has also said, where do you have any problems with water ingress? So the spoil and the water ingress in this case.
Okay, so spoil is all going to down the river to places like Ingrebourne Valley and Rainham marshes, where it's being used to cap landfill sites down in the Thames estuary. In terms of water ingress, I assume you mean water ingress into the tunnel. There are the occasional situation you get an occasional sort of damp patch in the tunnel. I've walked through the tunnels fairly regularly, and there are during construction you can get damp patches forming. Usually they seal up during the sort of the first few months that the tunnel is built. That's in the primary lining. We have a secondary lining that goes through the tunnel after the primary lining. So the segments that you saw in some of those pictures, that's the primary lining. Inside those segments, there's a cast in situ concrete liner that provides a secondary liner to the tunnel and further prevents any spillage of sewage out into the aquifers or groundwater into the tunnel.
Thank you, Roger. We've got quite a lot more questions to come. Mike has asked, gone back to that vortex, the vortex again, but asked whether you could generate electricity at the vertical drop. Is that a new green idea?
That's a good question. And in the early days that we looked at that, the problem is, although there's quite a lot of material coming into the tunnel over a typical year, it's very sporadic. So you could have 3, 4, 5 weeks with nothing, and then suddenly you could have a whole load of storms for days on end, and then nothing. That's one thing. Second thing, anything that you put in there to like a turbine, you've got to be able to maintain. And that means somebody would have to go down, maintain it. If that happens, the tunnel's out of action. So the two factors meant that it wasn't practical to use these devices as in that form. But it was something that we looked at.
Thank you, Roger. I'm just going through the questions. There's a couple there that have been answered already. Now, Paul asks, will the scheme enable more marine activity on the cleaner river? Is there likely to be an enhanced marine economy and skills training for young people who want to work on the river?
Yes, I think so. I mean, we will be cleaning up the river. That makes it much safer for people to engage with. And we would expect a significant increase of leisure activity, particularly in the west and of the Putney area, which is one of the big centres for rowing in the UK, the big centre for rowing in the UK. There's also a lot of other outdoor centres down in East London as well, in Deptford and Shadwell, just to name a couple, and at Royal Docks as well. So all of these will be, it'll be a lot safer and healthier for people, particularly young people, I guess, to get out there and engage with the river. The big problem, I suppose, about the Thames is its tidal range, which means that it is an inherently dangerous place to be if you don't know what you're doing with the tidal range. It's very large, and it can involve some significant flows of water, which make it it's not an easy place to dramatically increase leisure activity, but we do expect that to increase. And what we're trying to do, you mentioned about skills. I mean, we as Tideway are are funding and supporting the Thames Skills Academy, which is getting apprentices out on the river. It's getting training done, and it's looking at improving continuing professional development, so that the PLA have Port of London Authority have a strategy for significantly increasing the use of the river for all activities, leisure, tourism, passenger freight, etc. But to do that really needs an increasing competence of the river fraternity. And so we want to support that. We've shown on our project that we can deliver a massive increase by upskilling and improving the river operators through investment. And so we want to see that carrying on to the future. So yes.
Right, thank you, Roger. Well, the next one is Phil, who says it's possibly an ignorant question, but I don't think it is, because I have no idea what the answer is. He asks, why does the vessel carrying the tunnel boring machine upriver need the high columns at each corner?
Okay, it's a jack-up barge. The important thing is that TBM in the middle, 900 tons, is going to be driven off that barge onto the quayside. And the barge is, as you can see, is floating on the water below the level of the quayside. So those legs are driven down into the base of the river, and then the whole of that platform is ratcheted up so that the top of the barge is at the level of the quayside, and then it's driven across like you'd drive onto the ferry in Dover.
Thank you, Roger. Laura asked, what are the similarities with Crossrail? Was there any interaction between the two projects?
There was a huge interaction, actually. There are a lot of similarities, but there are a lot of differences too. I mean, big infrastructure projects in London, working close to neighbours, working in one of the world's most sort of built up areas. So those are all very similar. We worked very closely with Crossrail. We were very lucky. We had joint meetings with Crossrail back in the sort of 2012, 2013, 2014, and they were very, very good and very open at sharing stuff with us, particularly on health and safety. So Crossrail had generally a pretty good safety record, not perfect. Nobody has a perfect safety record, but they had a good safety record, and we learned a lot from them. They're very open, and we used their sort of endpoint as a starting point for where we wanted to go with our safety regime on Tideway. So we learned a lot. We learned a lot about that. In terms of technology, of the technologies between the projects, our tunnel's a lot deeper, so it's further away from buildings. So we haven't had anything like the issues with settlement of buildings and the sort of compensation grouting that Crossrail had to do. They were about 25 meters depth. We're about sort of typically 50 meters depth, and our tunnel doesn't have a railway and railway systems and people going through it. It doesn't have the mechanical, electrical follow-on work. It's basically, when it's finished, it's a hole in the ground made of reinforced concrete, which sewage goes through. So it's a lot simpler in its sort of mechanical complexity and electrical complexity than Crossrail is. But many of the skills in civil engineering are applied, and we've been very lucky in having the openness between the two projects to learn from their experience. Oh, you're on mute, Martin.
Gerald asks, has Abbey Mills had to be enlarged to handle all the extra effluent?
No, because Abbey Mills pumping station is really it's used to pump stuff up into the northern outfall sewer. That still happens. The existing classic sewer system that Thames Water own hasn't been dramatically changed or even significantly changed. What we've done is we've just provided a river, an alternative to the river. So the CSOs operate, and everything upstream of that. Well, maybe not everything. There are some changes. That would be wrong, but there's very little change to the Thames Water classic sewer system. Most of the change is the fact that instead of the CSO going into the river, it goes into the tunnel. And at Abbey Mills, instead of pumping up into the river, Abbey Mills discharges into the Lee Tunnel there at the moment. That's what happens right now. That's what will continue to happen. You're on mute again.
Yeah, there's a bit of noise in the background, so I've been muting. Brian asks, when is the Chambers Wharf site scheduled to be demolished and the piling in the river removed?
Oh, that will be in 2 to 3 years' time.
Thank you. That's a nice succinct answer. And Paul asks a question for us historian or history interested people. Are there any exciting archaeological expectations from the scheme, given that you are digging through virgin ground under one of the most historical cities in the world?
Yes, we've worked very closely with the Museum of London. Well, it's not English Heritage, it's Natural England now, I think, and Historic England, sorry. Yes, we have found some interesting things in the foreshore. I think the archaeologists are mostly interested in the sort of geomorphology of the foreshore and how it had moved over time, rather than sort of thinking that they were going to find some treasure. The most interesting thing we found was what we call the booted man. This is, I think, a skeleton that's 300 years old that was found in the foreshore at Chambers Wharf, and it looks like it's a man who was a fisherman, because they had striations on their teeth where they were using a fishing line. I think this guy had all that was left of his clothing was a pair of thigh-high leather boots, and if you want to, it got the most hits on our website of any story about anything to do with the Thames Tideway Tunnel, with the booted man. So, and that is now part of the archaeological sort of finds that the Museum of London is building up. We will be producing a report about others. There's been nothing. That's probably the most dramatic. We've had barrels that are a couple of 100 years old. We've had sort of old fish traps, if you can like, on the riverbed. But yeah, there's the odd coin, a few unexploded ordnances as well. Not quite archaeology, but despite a huge amount of surveying and UXO sort of checking activity, we still came across 2 or 3 of those.
Thank you, Roger. John asks, we've heard a lot about fatbergs. Is your tunnel vulnerable to these? Not really. The fatbergs are generally, they're up in the hinterland of the sewage network. They're up underneath places like Soho, and where there's a lot of production of fats and cooking stuff going down the drains. You don't see fatbergs in the river, so you won't see fatbergs in the tunnel, because basically it's replicating the river. So no is the answer. Thank you. Simon again asks, can your team fix Hammersmith Bridge, please? I'm not sure. I think perhaps that's a bit of a humorous question, but
yeah, I'm afraid not. That's a job for Hammersmith and Fulham.
Right. Move swiftly on. Mike asks, are there flexible joints where the geology changes?
No, not really. No, the geology doesn't change so dramatically that the tunnel needs to have joints in it. The tunnel, is designed to accommodate varying ground conditions, and there are where you're expecting something like a major fault, then stronger segments can be used, and we also have a secondary lining if we need to beef up the strength of the tunnel if we come across something that's problematic. So no, that's not really an issue.
Okay. And Catherine asks, what about the tributary rivers? Will they be cleaner? Will they reappear on the surface, as some people are asking?
Well, you take the main one. The answer is that they won't. They're all culverted over mostly. Some of them you can see them in various places, but say the River Fleet. The River Fleet was culverted over back in Victorian times. It runs under Farringdon Road. It'll still be a sewer. And we don't affect that. It's upstream. Our project basically will take the flows from the River Fleet when it is so high that it can't go down the normal system back will go into the tunnel. So the answer is we don't really change how London's sewer system works. We just stop the river being affected by the overflows. It overflows into the tunnel. The tunnel does the job that the river used to do, and it doesn't really dramatically affect the rest of the network.
Okay, thank you. Chris asks, the Crossrail boring machines were all named after iconic women. Who were these boring machines named after?
Iconic women. We had a competition. We came up with each of our boring machines has been chosen by the public. We came up with a short list for each of them based on exceptional women from the parts of London where our work is going on, and we then put it to a public vote, and I think we had something like 20 or 30,000 people voted. So you can go onto our website and you can catch all the names. I'm not going to, but Rachel, Charlotte, Ursula, Selena, Annie, those are some of the names, and they're all amazing women who did great things for London and for engineering and for other aspects of life. Thank you.
Roger asks, I got this out of sequence because he asked it some time ago. What are post office tunnels? ?
Well, these are tunnels that have been used in the past to move mail around London from trains. Yeah.
The post office railway.
Yeah, and there's GPO tunnels. There's various cooling tunnels and all sorts of things down there.
Okay. And the last one in the question and answer section, but we've got some in the chat as well. When the system this is Mick asking, when the system is up and running, how will there be any access to the actual tunnels for maintenance?
Well, we don't want to go down into the deep tunnels to maintain them. We want them to be pretty much maintenance free. It's 120-year design life, which means it starts to deteriorate in 120 years. So anything below about 15 meters, we just want to build it properly, and then leave it there. We will go down every now and again to have a look, and that, when I say every now and again, that's maybe every 10 years. Or we may go down earlier using remote devices, so we get a look at it, because there's pieces of kit now that can take photographs and move around remotely, because it's a dangerous environment down there, and if we can avoid putting people down there just to do an inspection, then so be it. All the equipment that does need to be maintained, there are various pen stops, gates, ventilation, odor management systems. They're all near the surface, and they can be maintained in the same way that Thames Water maintains its existing sort of sewer assets in London.
Okay, now we'll switch to the questions that have been asked in the chat. I'm not quite sure how many of those there are, but the first one is, a three-part question, so I don't know if you'll be able to remember all these or maybe read them in the chat yourself. Gilly asks, I understood that London's Thames was and is the cleanest river in Europe, cleanest city river in Europe, with over 120 different species of fish. With the pollution you described, is that not true? And she also asked, when will Vauxhall Bridge be fully reopened? It's chaos in these parts. And thirdly, do you envisage a Vaporati-style transport system on the Thames? I have no idea what that means, but maybe you know.
Sorry, I did a what style?
A Vaporetti-style transport system on the Thames.
Okay, so we've got is it the cleanest river?
The cleanest river, is it the clean river with the, are there,
Yeah.
what's the effect on the fish?
Yeah. Okay.
Vauxhall Bridge and the Vaporetti style transport system.
I don't know what Vaporetti is. It sounds like one of those sort of hyperloop type things with vacuum, but I've no idea, so I can't answer that. Vauxhall Bridge, again, that's a question for either Transport for London or Lambeth, whichever the local authority is there. I'm afraid I don't know the detail of that. I'm just as much affected as everybody else, I'm afraid. And as far as the river's concerned, well, yeah, and back in 1959, the river was declared biologically dead, and that was because of the industrial pollution that had been going into the river. Of course, that was dealt with by two things: a reduction in industry, number one, and also all the environmental laws that came in. And so I think, I remember when I was in my teens, salmon and dolphins and things like that, and people saying the river's a lot cleaner. And it has become a lot cleaner underlying. But what's been creeping up underneath that is the sort of the flow of sewage into the river. Now, that may not happen. Doesn't necessarily happen every week, and when it does happen, sometimes it's not as damaging as others. So when the temperature of the river is high, when the flow in is very severe, and the first flush of sewage, which is quite concentrated, comes into the river for some reason, and the fluvial flow coming over Teddington Weir is low, then there can be a serious impact on the oxygen in the river, which could kill fish. And I think back in 2014, sort of 500,000 fish. No, it wasn't 2014. It was 2004. 500,000 fish were killed. So that still happens as a sort of individual pollution effects. You've also got the situation that whatever Londoners put down the toilet in a storm, that gets into the river. So if you go to the Isle of Dogs and the inner bend of the Isle of Dogs, there opposite Greenwich, the rubbish and detritus that's deposited on that inner bend is absolutely disgusting. So a lot of that is going to be reduced significantly when we're fully in service.
Thank you, Roger. Right. Tim asks, why did the east tunnelling start so late after the other sections?
Good question. Because we had to build the sites that we worked on. If you look at the Chambers Wharf site, you'll see half of the Chambers Wharf site is temporary. It's made of building a very large cofferdam out into the river that is temporary, that we taken away at the end of the project. So we had to get into Chambers Wharf. We had to demolish certain things. We had to clean up material that was left there from the previous use. We had to build this large wharf out into the river. Then we had to prepare all the ground and everything else. Significant geotechnical works required there for shafts, for grouting. There are 3 tunnels coming together there, so there are 3 reception chambers to be prepared, or launch chambers underneath there. So you know, a huge amount of civil engineering work has been done at Chambers Wharf before the tunnel boring machine went down the shaft last Friday. And here we are, we're 60% through, or nearly 60% through our job. So, you know, we call it a tunnel, Thames Tideway Tunnel, but there's a huge amount of non-tunneling work required to enable the tunnel to actually be built.
Thank you. Well, I think we've come to the end of all the questions, except that it has been revealed to us that Vaporetti are the timetabled riverboats of Venice. So I don't know whether you have any control over scheduling gondolas and riverboats carrying passengers.
Well, there's the new Uber boat service on the river provided by Thames Clippers, which I've had I use when I did go into an office 6 months ago. I commuted by them from Putney into the London Bridge area. Great service, and it's it's coming back now, which is fantastic.
Right, well, there are a number of other comments in the chat that are praising you for a very interesting talk. We've had, I think, a record number of questions, and indeed we've had a record number of people taking part, up to our limit of 100 participants on our Zoom account. So I think the time now has come to thank you very much. I hesitate to say that it was a boring talk, but of course boring was the subject. But it certainly was a fascinating talk. So we do thank you very much indeed, Roger, for giving up your evening to come and talk to us. The audience, we were talking this afternoon about where the audience was, and I was saying that we didn't know, but one or two people have revealed that they're a long way from London. So the audience extends from the south coast of England to the very north of England, and I'm sure they have all enjoyed it. We can't clap on Zoom, I don't think, but I think you may take it that raised hands are appearing, so these are applause. So take the raised hands as virtual applause, and there's lots of those coming through now. Thank you very much indeed, Roger, for your presentation.